Good morning, students. Today we will discuss about electron orbits. As you know very well the structure of the atom, the nucleus is present exactly at the center and all the electrons they are revolving around the nucleus. That is the reason, as you know very well, because of electrostatic force of attraction, all the electrons are revolving around the nucleus. And here there is a word, there is a concept, that is electron orbits. What do you mean by electron orbits? The orbit is nothing but that is path of the electron in which that is electron is revolving around the nucleus. Means how to define this electron orbits? This is path of the electron in which they are revolving around the nucleus. Those are called as orbits. The first, that is definition. The definition of electron orbits. What is that one? Path of electrons revolving around the nucleus called as electron orbits. Around the nucleus called electron orbits. As you know very well, the structure of the atom, that is, this is called as positively charged center called as nucleus. The nucleons are nothing but proton and neutron together. They are concentrated exactly at the center, occupying very small space, a small value, that is called as a nucleus, and these are called as orbits of the electrons. It means that here in each and every orbit the electrons are revolving around the nucleus. What is the reason behind this one? That is, there is an electrostatic force of attraction between the negatively charged particle, that is the electron, and positively charged center, that is nucleus. And here its charge is, the nucleus having the charge, that is plus Z into E. Here what is E? This is charge of proton. Actually here two particles are there, one is a proton, another one is a neutron, but we are not considering the charge of the neutron because that is chargeless. And here remaining one is proton is there, its charge is plus E. And here the total charge of this proton becomes the number of protons into charge of one proton. The number of protons in the sense, that is Z. Z is nothing but you are going to take, that is atomic number. Atomic number in the sense, that is, it is Z indicating atomic number in the sense, that is indicating the number of positive charges. It means number of protons concentrated in the nucleus, that is indicating the atomic number Z. And charge of one proton, number of protons into charge of one proton, if you multiply by getting the total charge of this nucleus. And next, as you know very well, the charge of electron, that is minus E. Just minus, what is indicating this is the magnitude is in negative, that is minus 1.6 into 10 to the power minus 19 coulomb is there. This is E is nothing but here minus E is nothing but charge of electron, and here plus Z is nothing but this is charge of nucleus. And here in each and every orbit these electrons are revolving around the nucleus. What is the reason behind this one? Let us take here. This is electron is revolving around the nucleus. The reason is behind this one. That is because there is an electrostatic force of attraction by the nucleus towards its center. As you know very well, one is a centripetal force, another one is a centrifugal force. These electrons experiencing the centripetal force of attraction by the nucleus. Just you can imagine, if there is no, if this nucleus is not attracting this electron, then what is happening? If this nucleus is not attracting the electron, means there is no electrostatic force of attraction, then what is happening? If the electrostatic force of attraction between nucleus and this electron is 0, means there is no electrostatic force of attraction between nucleus and electron, then what is happening? Instead of revolving, this electron is moving somewhere. Means this electron is leaving its orbit and it is jumping to some other place or some other point. And it is not jumping unless and until it is receiving some energy. This electron, it is stationary orbit. This electron is revolving continuously around the nucleus, and this electron is revolving around the nucleus continuously. But instead, it is not moving anyway. What is the reason? Because this nucleus is not leaving those electrons to go out. nucleus is not leaving these electrons to go because there is an electrostatic force of attraction. Whatever it is the position of electron while revolving, this is the position of the electron, or else this is the position of the electron, or this is the position of the electron. Whatever it is the position of the electron in the orbit, but continuously there has been an electrostatic force of attraction by the nucleus towards its center. That's what these electrons are not leaving the orbit until and unless they have received some energy from the outside. That's why these are the orbits of the electrons. In different orbits are there. Depending upon their energy or orbit energy, the electrons are revolving around the nucleus. That's why here the concept that is electron orbits. That is the path of electrons revolving around the nucleus. That is called as electron orbits. And let us consider there is an electrostatic force of attraction between this nucleus and this electron, and that is depending upon R. This R is nothing but this is center of distance between nucleus and center of the electron. This is R. Again, the electrostatic force of attraction between nucleus and this electron, that is depending upon R. Again, we have to calculate. And again, the electrostatic force of attraction between nucleus and the center of the electron, that is again we have to calculate by using this R. And let us consider whenever the electrons are revolving around the nucleus, their velocity is always tangent to the orbit. That is velocity of electron. It means if this nucleus is not attracting this electron towards its center, then what is happening? This electron is moving exactly tangent to the orbit. But whenever this electron is trying to go away from the orbit, then this nucleus, what it is doing? It is attracting. Instead of going out, this electron is moving again here. But at this point, it is trying to go. Then whenever it is trying that, simultaneously or suddenly this nucleus is attracting the electron towards its center. Instead of going away, again it is coming here. Means this process is going on. That's why the electron is not leaving its orbit. And let us consider. Here I am calculating. Consider the charge of the nucleus, that is, consider a charge of electron or nucleus. Charge of electron, that is E. And what is the charge of the electron? That is just you can consider mass, that is M. And mass of electron is M. And next consider the charge of nucleus, that is plus Z. Z is indicating number of positive charges at the center, and E is charge of one proton. If you multiply number of charges into charge of one proton, you are getting total charge of the nucleus. And next one, the electrostatic force of attraction between electrostatic force of attraction. Just you can consider only one electron. Just you can consider this electron or this electron or this electron. Just our intention is to find out the electrostatic force of attraction between nucleus and electron. If you consider this electron, you have to consider this as a distance. Or if you consider this electron, you have to consider this as a distance. That is depending upon the electron what you are considering. The R is boson changes. The electrostatic force of attraction between electron and nucleus is given by, as you know very well, there is a theoretical formula you studied already in the first topic, that is electrostatics. That electrostatic force of attraction between negative particle and positive particle, that is given by the Coulomb's law, that is F is equal to 1 by 4 by epsilon naught Q1 Q2 divided by R square. And this is the constant value electric permittivity. Q1 is charge of the one particle, Q2 is charge of second particle, and R is the center of distance between those two particles. Here one particle is nothing but you can consider it as a nucleus, another particle is an electron. And how much is the electrostatic force of attraction existing in between these two particles? If you calculate that one, you can use the Coulomb's law, that is 1 by 4 by epsilon naught Q1 Q2 divided by R square. Here Q1 I am taking it as, what is Q1? I am taking it as a nucleus. What is the charge of nucleus? That is plus Z into E. And next, what is Q2? Q2 is nothing but that is electron, and its charge is that is E. You can take minus E or just E. The minus sign indicating that is the magnitude of charge is minus. And next one, calculate this one, simplify. F is equal to 1 by 4 by epsilon naught, and Z as it is E into E, that is E square divided by R square. Let us take, this is the equation number 1. By using the equation number 1, what we can do here, we can possible to calculate what is the electrostatic force of attraction between the nucleus and electron. Here only changes is R. If you want to find out the electrostatic force of attraction between these two, then you consider this as R. If you consider the electrostatic force of attraction between these two, you can consider this as R. That is depending upon the which orbit you are going to consider here. That is depending upon the R is boson changes. And let us take this is a equation number 1. And next one, the electrons are revolving around the nucleus, because the centripetal force, therefore the centripetal force is providing to the electron, the centripetal force provided to the electrons, that is by electrons by nucleus, or electrostatic force of attraction. Electrostatic force of attraction by the nucleus. Let us consider here, if there is no electrostatic force of attraction, let us consider this as a nucleus, this as an electron. If there is no electrostatic force of attraction between these two, then what is happening? This electron, actually there is a centripetal force and centrifugal force is there, and remove centrifugal, because whenever if the electron experiencing a force of attraction away from the nucleus, then you can call it as a centrifugal. But here the electron experiencing the force of attraction only towards the center, means this is centrifugal or centripetal, this is centripetal, because the continuously there has been a force acting on the electron that is towards the center, that's why it is centripetal. And who provides this centripetal? Let us consider, if there is no electrostatic force of attraction between these two, what is happening? I am considering, if there is no electrostatic force of attraction between these two, then this electron is not revolving. Instead of revolving, it is leaving the orbit. That's why it is revolving continuously in this orbit, means because of which reason? That is because of electrostatic force of attraction. If nucleus is not attracting the electron in the sense, the electron is not revolving. Instead of revolving, it is leaving this orbit. Means in order to keep this electron continuously revolving around the nucleus, then what is the reason? That is the electrostatic force of attraction. Means who provides the centripetal force to the electron? That is electrostatic force of attraction provides the centripetal force to the electron. That's why the magnitude of centripetal force is always equal to electrostatic force of attraction between these two particles. What is the reason? Because in order to get the centripetal force, who will give that centripetal force to the electron? The electrostatic force of attraction gives the centripetal force. That's why the magnitude of centripetal force as well as the magnitude of electrostatic force of attraction both are equal. But the centripetal force of this revolving electron, how to calculate that one? There is a formula, that is centripetal force of that electron revolving around the nucleus, that can be calculated by using the formula, that is mv square divided by r. What is this, sir? R is distance between center of the nucleus to the center of electron. What is v? This is orbital velocity. Means with which velocity or in what velocity the electron is revolving. That velocity is called as a orbital velocity. Why you are calling it as a orbital velocity? Because the electron is revolving in the orbit. That's why the respective velocity is orbital velocity. And what is m? This is mass of electron who is orbiting. The electron is orbiting. That's why the m is indicating, that is mass of the electron. Let us take this is a second equation. And here from the second equation and the first equation, the magnitude of centripetal force is exactly equal to magnitude of electrostatic force of attraction. That is reason, because the electrostatic force of attraction only provides the centripetal force to the electron. That's why if its answer is 10, then electrostatic force of attraction is also 10. The magnitude is same. That's why equate the equation 1 and 2. Equate equation 1 and 2. That's why mv square divided by r, this is equal to equation 1, that is electrostatic force of attraction, 1 by 4 by epsilon naught, that is Ze square divided by r. And here r are getting cancelled. This is r square, r are getting cancelled. This is mv square is equal to remaining what? 1 by 4 by epsilon naught. Then this is Z into E square. And let us take this is mv square. And how to calculate the kinetic energy of these electrons? The electron is not in rest, it is moving continuously, in the sense it is having a velocity, it is gaining a velocity. It has the property of velocity in the sense its kinetic energy can be calculated by using the formula, that is 1 by 2 mv square. Therefore, the kinetic energy of electron can be given by the theoretical formula as kinetic energy is equal to 1 by 2 mv square, 1 by 2 mv square. And here substitute mv square value you already found out here, substitute in this equation. Therefore kinetic energy becomes 1 by 2 as it is. mv square can be written as Ze square divided by 4 pi epsilon naught. And in the further step it can be written as kinetic energy is equal to 2 into 4, that is 8 and 8 pi epsilon naught and Z into E square. I am writing only E square because for hydrogen atom Z is 1. For hydrogen atom I am taking the consideration of hydrogen atom, then Z value for hydrogen atom is 1. Only it is having 1 proton, that's why Z is 1. Substitute here Z becomes 1. Remaining is E square divided by 8 pi epsilon naught. And let us take this equation as 3. And next one, we calculated now the kinetic energy. And next we can calculate potential energy. Why I am calculating these two? Because our intention is to find out what is the total energy of that electron revolving around the nucleus. That's why kinetic energy is the total energy. In order to calculate the total energy, we have to calculate the kinetic energy as well as the potential energy. And therefore, I am writing directly the potential energy of electron. The potential energy of electron in the orbit is given by directly I am writing that is equation 1 by 4 by epsilon naught, that is Q1 Q2 divided by R. Whenever you are going to calculate the electrostatic force of attraction, Coulomb's law, that is F is equal to 1 by 4 by epsilon naught Q1 Q2 divided by R square. But whenever you are going to find out the electric potential energy between these two charged particles, then we are going to consider this as a R, not its R square. There is a difference in between force and potential energy. This is not a R square. And let us substitute And what is Q1 here? Q1 is nothing but charge of the proton. I am taking that is Z into E. And what is Q2 here? That is charge of electron. I am taking that as E. And always electric potential of that electron is always in negative. What is the reason behind this one? Let us consider. This is the atom, this is the nucleus, here electron is there. Just you can imagine yourself, this is in rest. Whenever the particle is moving in the sense, it is possessing the kinetic energy. Whenever you are taking the consideration of rest of the particle, it is possessing the potential energy. Let us consider here the electron is present at this point. It is having the potential energy that is negative. Why it is negative? Let us consider. Its potential energy can be calculated with respect of this position, can be calculated by using this formula. But I am taking the consideration of minus sign. What it is indicating? Let us consider. This electron, whenever it is present at this point, it is having this much of potential energy, and that too it is having negative potential energy. Let us consider this electron is not leaving the orbit. Why? Because the nucleus is continuously attracting the electron. That's why it is not leaving the orbit. And let us imagine yourself, in order to move the electron away from the orbit, what we can do here? Here, just you can imagine this is the electron present here, and its potential energy is this much. That is negative. But our intention is to move the electron away from the orbit, or eject the electron away from the orbit. Then what we can do? Now you need to do potential energy is equal to 0. But now the electron is present here, its potential energy is not 0. It is having a negative of this much value. But our intention is to emit the electron from this orbit, or take the electron away from this orbit. Then what we can do? You need to do its potential energy that is equal to 0. Then how to do? You need to supply a potential energy that is positive potential energy. How much? That is 1 by 4 pi epsilon naught. That is Ze into E divided by R. This is having negative potential energy at this point. If you supply this much of potential energy to this electron and its potential energy becomes 0, then this electron is leaving the orbit. This is in minus, this is in positive. Both are cancelling with each other. Then this potential energy plus this potential energy, you are getting potential energy is equal to 0 because it is positive, this is negative. Whenever potential energy becomes 0, then electron is leaving the orbit. That's why now it is not leaving the orbit. It is present at this point only. That's why it is having negative potential. What is the potential energy? That is, it is work has to be done by the electron in order to leave the orbit. That energy is called as potential energy. That's why I am taking the negative sign here. But the electron is not leaving the orbit. In order to leave the electron in this orbit, it has to do some work done, that is positive work done. Or positive potential energy you have to supply to this electron in order to take the electron away from the orbit. That's why the potential energy of each and every electron is in negative here. And let us take this equation as this one is fourth equation. And here the kinetic energy can be calculated by using this formula, and potential energy can be calculated by using this formula. And you can further simplify this also. Potential energy is equal to, that is 1 by 4 by epsilon naught, and next Z into E, that is Z into E square divided by R. For hydrogen atom Z is 1. For hydrogen atom again Z is 1. Substitute, potential energy becomes 1 by 4 by epsilon naught. Again this is E square divided by R. And I am taking it as a minus because each and every electron in its orbit having a negative potential energy, and therefore you calculated the kinetic energy as well as the potential energy. Then total energy of this electron, total energy means that is the sum of kinetic energy as well as the sum of potential energy. Means whenever the electron is moving around the nucleus, and what is its energy? That is kinetic energy. And whenever the electron is in rest, that is what the energy that electron is having, that is potential energy. And total energy in the sense you can add up those two, kinetic energy plus potential energy, and total energy is equal to, that is E square divided by 8 by epsilon naught R plus, and this is in minus, E square divided by 4 by epsilon naught R, and again this is in negative, plus minus again minus, then dV is equal to, take the LCM, you are getting the answer E square divided by minus, that is 8 by epsilon naught R. This is the total energy of this electron. Just you can take the LCM and find out the value. You are getting the equation like this: minus v square divided by 8 by epsilon naught r. And whenever the electron is revolving around the nucleus, its total energy can be calculated by using this formula. And here the negative sign just indicating the there is a electrostatic force of attraction. Means here the positive particle, this is a negative particle. In the sense, what is the nature of the force between these two? If the nature of the force between these two is attractive, then we are indicating by the sign as negative. And if there is an electrostatic force of repulsion is there, if there is a repulsion, then we are taking it as a positive. If there is a attraction is there, we are taking there is a negative sign. And let us consider, by using this equation, it is possible to find out the total energy of that revolving electron. And this equation, for example, I am taking the first orbit, and if you take the second orbit, in order to calculate the energy of this electron also, you can use the same formula, but only change in the value, that is R it changes. And again, for third orbit, fourth orbit, fifth orbit, so on, it is applying to nth orbit. And by using this equation, and it is very important for your examination also, and you can remember this derivation, and this is indicating the derivation of the energy of each and every electron around the nucleus in its respective orbits. That's why this one is the concept of electron orbits. And remember the definition as well as and the derivation. And next there is a concept atomic spectra is there. We'll see in the next.